Hello and welcome to this presentation from the Royal Blind Learning Hub. My name is Anna Crystal and I'm a qualified teacher of the visually impaired at the Royal Blind School. I'm going to be talking to you today about making tactile graphics, specifically graphs and charts as you'd be using in maths and science. So I'm going to start with a slide that describes some of the challenges. Clearly, reading and producing charts can be very challenging for students who are blind or severely visually impaired. And as a teacher, you really have to specifically teach them how to interpret and to make these graphics. And in doing that, this is really very, very key to their success in any qualifications, any examinations in maths and science, and to their progress generally in these subjects. Okay, so this slide shows the outline of what I'm going to talk about today. You see it's in two parts. The first part is going to be concentrating on how a pupil would go about producing graphs. The second part is about how I or a support worker would go about producing graphs that they would then be reading and using in class. Again, this is a little bit of a summary slide just to show you the sorts of graphs and charts that I'm talking about. So we've got bar graphs, we've got dot plots, we've got histograms, scatter plots, line graphs, coordinate charts, box plots and pie charts. So I'll hope to try and touch on all of those in this presentation. So as I said, I'm going to start by looking at how a pupil can go about producing tactile graphs. So in terms of a pupil plotting points on a graph, you want to think about the number of data points and the values. If a pupil is going to be plotting their own points, it is going to be much easier for them if those points are on the intersections of the grid lines. It will take them longer than it will do their sighted peers, and so therefore you want to think about how many data points you want them to plot out. Obviously with practice that does get quicker, but it is a time-consuming process, and that's to be aware of. So in order to do this, the sort of equipment you might need, you're going to need a Perkins Brailler and some Braille paper. Now you might use embossed grids, such as down in the bottom right of the screen there. These can be purchased from suppliers like the RNIB, or you can produce your own graph paper, as you can see on the top right of the screen. This is produced on swell paper, and this can be quite useful for pupils who have some vision but who are largely using touch for accessing the curriculum. Obviously the bold lines make it easier for them to use that residual vision. In both cases, when they're plotting the points on the graph, if we're doing line graphs, you're looking at pinning this to a corkboard and using pins and elastic bands to plot. A spur wheel is very useful for making any lines permanent. Drawing mats and plastic embossing film I'll also be talking about later on, as will I touch upon using wiki sticks too. So just really this slide is outlining the sort of equipment you're going to need to do this. However, I'm going to start first of all with pupil producing a Braille bar chart. And I've got a question here, typical sort of question they might be required to do. I think this question came from a National 5 biology paper. And so a pupil could be required to produce a bar graph, as it's shown here, that is looking at perhaps 4 or 5 different types of cell, and you've got the average cell sizes to plot. And this slide here shows how that could be done. So you're using just standard Braille paper, and what the pupil would need to do is come up with a scale. You're using all 6 dots, so 1, 2, 3, 4, 5, 6, the 4 sign to equal a certain number, and then you would use your dots 1, 2, 3 to represent half that number. So you can see on this particular example, the 4 sign is equal to 2 and the L sign is equal to 1. And as long as Pupil provides that key, you can then very quickly produce a graph just by multiplying up the numbers there. So what I would expect the pupil to do is to, if they're working in Braille, to put the title for the type of cell on the left-hand side and then list the various options there. And then they would be lining up the start of their bars and then producing the right number of cells to represent the different bars. And you can see again the axis title is just up above those bars, and that is important. I have seen examples where people would also put in a line between the axis titles and maybe produce a scale. But depending on what you're wanting to do, this is a very simple form of producing a bar graph that is obviously representing the data and can be read quite simply by interpreting the scale. Okay, we're now looking at Braille line graphs, and here we can see some of the Swell paper produced graph paper. You can see that this has been pinned onto a corkboard with 4 pins at the corners of the board. Before plotting the graph, obviously you would need to put on your Braille labels and scale, and that can be done by feeding the paper through Perkins Brailler. And then you're marking the plotted points according to that scale with pins. Now you can see that in this example we've got the pins all lined up on the left-hand side of the board, and that's quite important to help the pupil do this as independently as possible if they know where the pins are located. As I said, you mark the points with the pin. Obviously it's easiest, as I've said previously, if the points to be plotted are at the intersections of the grid lines, but as the pupil gets more advanced and their understanding of line graphs increases, it's probably quite reasonable to expect them to do a little bit of interpolation within that. But you have to accept that the accuracy in that is going to be different from their sighted peers. Having marked the pins at the correct positions, the pupil can then use an elastic band to mark the position of the line and to tactilely feel the line and the relationship between your 2 variables. And once they've explored that line and have understood what the line graph is representing, if you want to make a permanent record of this, you can turn the page over, and on the reverse, if you use a spur wheel, you can mark a line so that the pupil can feel a tactile line between the points on the diagram. Alternatively, if it is more for the teacher's record, you could just use a black marker pen to create that line. If you need to do a line of best fit on a line graph, you can position 2 pins that represent, use a ruler to line up the best line of fit, hold it in position with 2 pins, and then use an elastic band again to mark that on the graph. So here we've got an example of a completed Braille line graph. So again, you can see the pins on the left-hand side, the pins holding the graph paper in place, and the plotted line marked by elastic bands. So you can see how this is enabling the Braille user to produce a line graph, explore the relationship between the variables in the same way that their sighted peers would. Also on that diagram, we're showing a spur wheel that you can mark the paper to create a permanent record with. From behind gives you the best representation of that, and a permanent marker as well for recording. Again, if we're looking at doing a Braille coordinate graph, we have got our embossed graph paper here, and I have used wiki sticks, which are the sort of waxed strings, and they can be stuck to the paper, and they're quite good at staying in place. So you can mark out your axes with that. Again, if you need to mark your scale, that can be done either by feeding it through a Perkins Brailler, or you could maybe use a Dymo labeler instead. You can see I've used the Dymo label on this particular example just to mark your X and your Y axis. Pins, again, used to mark the particular points. And you can see on this example, I've used a different type of pin just to mark the origin, the 0, 0 on this graph. Right, we're moving on to how a pupil would produce a Braille pie chart. And I've got 3 different examples here on the slide. On the left-hand side, we have got a pie chart produced using swell paper. And you can see on this particular pie chart, the radius is already marked in, and we've used again a map pin just to mark the centre of the pie chart. This particular pie chart is subdivided so that the pupil is having to count round to work out different angles. So it'd be quite a good one maybe to start somebody learning how to produce a pie chart. Again, we've used the wiki sticks, the wax strings to mark out the segments. And if you needed to label that, again, you could use either sort of sticky adhesive Braille, cutting it out to mark that, or the Dymo to mark the different sections, possibly with a key there as well. In the middle of the screen, I have got an example of a circle being drawn onto just standard Braille paper, placed on a drawing mat, and on the right of that picture we've got a spur wheel compass. So this is quite a useful device that produces obviously a raised circle that can then be used along with the protractor to produce a pie chart with specific angles. The pin could be used maybe to mark the centre of that circle where the hole from the compass is, and spur wheel could be used to draw the lines to the circumference or the outer part of the pie chart. Final example there is using what's called plastic embossing film or German film. Here we've just drawn a circle with a standard compass using a pen, standard biro. If you write on plastic embossing film with a standard biro, the line becomes tactile, raises up, and you can see how we can then produce a simple pie chart with that, again using a drawing mat underneath. Sometimes when you're teaching in maths and science, you want to do a basic sketch graph. We're not looking here at accuracy in plotting, we're just trying to look at the relationship between variables. And you can see here, again, we're using the plastic embossing film placed on a drawing mat and just drawing a basic sketch graph. Again, we can add Braille labels by putting it into a Perkins Braille if you use a bit of Braille paper as backing. Or we could also produce a quick, simple sketch graph using wiki sticks. So we're now looking at actually producing graphs in Braille. Obviously, when we're teaching maths and science, quite often we're actually providing the pupil with graphs. And so when we're looking at providing perhaps past paper materials, we're adapting materials that have come from the examination board. So certainly if it is for things like prelims or for preparation for examinations, you want to be making sure that you're producing them in the format that kind of corresponds to what the pupil is going to experience in the exam. And here in Scotland, that would mean referring to the SQA guidance on how to do that. For those of you who are new to this, that can be found on the SQA secure site, and you're looking for a document called Additional Guidance for use when requesting adapted question papers and artwork. Key principles, this is something you can go into a lot more detail with. Key things to think about really are that you have to often enlarge the graphs and they often need a lot of simplification. As I've mentioned previously, when we were talking about the pupils actually plotting graphs, again, you might want to consider modifying the number of data points if you're looking to read that graph, and possibly alter some of the values so that they can be easily read by intersecting the grid lines. To make things accessible, clearly we will need to remove any shading, which could be confusing on a tactile graphic. So on the next few slides, I'll just give you a little indication of some of the challenges that you may encounter when adapting graphs. This is an example from the SQA National 5 Biology paper, where we've got obviously two dependent variables plotted. So that's quite a challenging graph to produce. Here we've got another biology graph where we've obviously got a lot of information and a lot of data to read. And here again we've got another biology example, just where you've got a graph that's got a lot of shading that would obviously be very difficult, make it very difficult to read the actual plotted points on those graphs. So how do we go about making tactile graphs and charts to present or to give to our pupils? Well, obviously one way we could do that is to use graph paper and just to hand draw or tool that for the pupil. Obviously that's quite time consuming, and if you ever need to repeat that, you've got to start again at the beginning. So certainly if you want to produce multiple copies, if you want to have a good starting point to do this again in the future, it's quite useful to have to use word processing programs or things like Excel to give you a good starting point. And the key thing really to start with is to make yourself some graph paper. So I've just put a reference there as well to an online version of making graph paper that you might find useful. However, what I'm going to show you is how to actually make your own grids to your own specification using the sort of standard Microsoft Word package. So in order to do this, I've broken it down into several steps. The first step is to insert a table. So we're looking to the Insert menu, and you can see I've shown you what then comes up, and we're putting in a table. I've selected for this particular table 11 columns and 11 rows because I want to make some graph paper that is going to be 10 by 10 grid squares. Okay, hopefully that will become clear why I've done that as we go through this. So when you do that, what first comes up on the screen is something that it doesn't look particularly useful. So what we need to do in step 2 is to alter the row height and the column width, just to make it into standard squares. So what you would do in this is you would go to, you select the whole table and use the Table Tools menu to select the cell size group. Okay. So again, I've got a little screenshot there just to help you find or locate that. In this example, I'm making grid squares that are 1.5 centimetres by 1.5 centimetres. Obviously, you can adjust that to make them larger or smaller according to the individual needs. Having done that, we then want to adjust or alter the line thickness for the grid lines. So again, we're selecting the whole table. And we're going back to Table Tools, and we're looking at the Design tab and Drawing Borders. For this example, I've highlighted in red where you can find the Borders tab. We're selecting all borders, which means that every single square is going to be outlined, and I've gone for a 1 point line thickness, so thicker than standard. Having altered the line thickness for the grid as a whole, I now want my axes and tick marks to stand out. Tick marks are the little lines underneath the axis that correspond to the data points. And that's quite useful for our tactile learners in terms of lining up and checking that they're reading the right number. So what I would do here is I would be selecting the first column of the table, going back to our Table Tools, going back to the Draw Borders group, and this time I'm going for a thicker line, so I've gone for a 3 point line thickness. I would then go to, again, to the Table Styles group and select all borders and that would hopefully make all that first column a much thicker outlined grid. I would then do exactly the same, but this time selecting the last row at the bottom of the table and just making that, again, all surrounded or outlined in 3-point line thickness. So having done that, this is hopefully what you have got on the screen. Okay. So I've mentioned already that tick marks are quite useful, enabling the pupil to line up the value with the grid line. So here what we're going to do is we're going to select a shape. So we've gone to the Insert menu and we're selecting Shapes, and I'm selecting a rectangular shape, which I'm going to use to hide half of that first column. So you drag it and lengthen it so it covers half that first column. I'm then going to repeat that to hide half of the last row. So again, just to show you what that should look like, we've got up on the screen there 2 rectangles hiding that first column and that last row. Now, as usual, it has used those, they've come sort of with the sort of auto colour and auto outline. So the next step is to basically hide that shape. So we're going to the drawing tools, we're going to format, and we're looking at shape styles. Again, we've got a little screenshot there just to help you find what we're looking for here. In order to hide the grid lines underneath that shape, I'm choosing white for my shape fill. And to make sure we don't have any outline, I've chosen no outline. And what we then should have is something that looks like this. We've got 1.5 times 1.5 grid squares with thick axes and tick marks. And that's a good starting point to then create either a bar chart or a line graph or some sort of standard graph that you would find on graph paper. Clearly, other graphs and charts can be created in the same sort of way. On the screen here, we've got a couple of examples of pie charts that have been created using, again, Microsoft Word drawing tools. So we've made our graph paper, and the next thing we need to do is we're going to use that existing grid and overlay it with bars or lines and add Braille labels to the axes. Obviously, in order to do that, you would need to have a Braille font installed on your computer, and these can be downloaded quite simply online if you just do a search for Braille font. So if we're doing a Braille graph, what we're wanting to do on the x-axis for our scale, we've got here numeric scale, we're wanting to make sure that the vertical component of the number sign aligns with the grid line. So you can see at the bottom of the screen here that for the horizontal, the x-axis, the number sign is aligning with the grid line. On the y-axis, we need to make sure that the horizontal component of the number sign is lining up with the grid line. And again, that just helps our Braille user to sort of locate the grid lines quickly and easily. Onto this particular graph, you can see that I've plotted a line. I've used, again, a different line thickness, in this case 6 point, just to make that easy to distinguish from the grid lines and from the axis. And I've used an open circle of 6mm diameter just to mark the plotted points. Okay. So what we need to ensure when we're teaching pupils to read graphs and to access graphs when they're doing graph questions is they need to be able to quickly explore that graph and get the sense of what the graph is all about quickly. So in order to help them do that, it's really important that we present it in a sort of systematic way. And I would suggest that the graph title should always be at the top of the page. Any labels should be brailled horizontally on both the x-axis and on the y-axis. So normally that would be putting your label up above the y-axis would be the simplest place to put that. You want to make sure that the graph that you're giving to the pupil to explore isn't slipping around the table. So I would normally put that on a piece of non-slip Dyson. And I would encourage the pupils, first of all, to explore the diagram, scan the diagram quickly with both hands to get an idea of what type of graph it is, how big the graph is, and how complex, how many data points there are. Then I would get them to read the title and read the axes labels, read the key, if there's a key, for the pie chart, for example, and then identify the scale. And it's only at that point we then start looking at identifying particular plotted points. Okay. So I'm finishing up here with just some examples. So just showing you a Braille bar chart that was produced for pupils to read. So you can see in this the principles we've talked about. We've got grid lines. In this case, we've used sort of dotted grid lines just to distinguish them from the axis and the plotted bars. The axis thickness is greater than the grid lines. We've lined up our numbers with the lower part of the number sign aligned with the tick marks. And you can see that I've done this in print just so it's not all Braille, it's a bit more accessible for most of you who are listening to this presentation. We've got all the names of the different surfaces written there underneath each bar. I've used open bars here just, again, to make it easier for the pupil to track along and back to the vertical axis to read off the force values. Here is an example of a Braille dot plot. Again, this can be produced quite easily using the Microsoft Word tools that we described earlier. The box plot. Okay, and again, seeing the principles of lining up the vertical component of the number sign with the tick marks there. And here we've got a Braille line graph. Again, I've got a combination of print and Braille on here just to hopefully make it a little more accessible. Produced obviously as I've described it. You can see the label for the vertical axis at the top there, horizontally, with the units in brackets after that. And the other thing I would point out on this particular graph is we've added arrows to the axis, again, just using basic tools. The final screen here is just showing you an example of a Braille pie chart. Here we've got the subdivided pie chart. We've got the example of using a key, so presenting the key just underneath the title, and you can see that it's labelled then quite simply with just a letter within each part of the pie chart. Okay, thank you very much for listening. I hope that's been useful for you. Bye now.